All right, hello. I've been having some issues with Loom, so I'm going to use a different thing. So excuse that you can't see me, but I am so excited to introduce you to your last 7th grade science unit. Woo woo! You made it! Let's talk about waves and the electromagnetic spectrum, okay? So this is just going to be an overview for what we are learning about. So our first lesson is about wave properties. But first, what exactly is a wave? A wave is any disturbance that transfers energy from place to place. Okay. The best way to look at it is through slinkies or ropes. So if you are pulling a rope back and forth, that shows a wave. Okay. So there are two types of waves, a mechanical wave and an electromagnetic wave. The difference between those two is that a mechanical wave needs matter to move through. Okay, so it needs particles. It needs to be in a solid, a liquid, or a gas. An electromagnetic wave doesn't need any of that. It could travel without matter, so it could travel in a vacuum. An example of a vacuum is actually space. So electromagnetic waves can travel through space, mechanical waves cannot. Then there are some more types of waves. There's a transverse wave, and a longitudinal wave, and a surface wave. A transverse wave is that bottom picture right here. It travels perpendicular to the direction of the source of motion. So I think of the transverse waves as the more common wave. So when you're drawing a picture of maybe the beach or the ocean, you make those squiggly lines to demonstrate a wave. And that's a transverse wave. Okay, that's how you show a transverse wave. Okay, so it's just the particles are traveling perpendicular to the direction of the source of motion. So that means if I am pushing some wave or something to the right, the particles are actually moving back and forth. Okay. So with a longitudinal wave, it's different. Longitudinal wave travels in the same direction as a source. Okay, so that's this first picture right here. That's a longitudinal wave. Okay, so if I am pushing or pulling the slinky, you see those compressions or the really compacted slinky swirls. That is showing that the wave is going in the same direction. It's not going up and down. It's going in that same direction of that push or that pull. Okay. So transverse, up and down, longitudinal, it's the same direction. And then there's a surface wave. That's just a mix of transverse and longitudinal waves. An example of this is the ocean waves. Okay, and we'll get into that more when we talk about it during lesson 1. Next lesson is wave interactions. Okay, so there are many different interactions that waves can have either with itself or with different objects or with another wave. Okay, so first let's talk about reflection. That's a wave that bounces off an obstruction or an object that heads in another direction. So this picture right here shows it best. Another instance is if you've ever wore something shiny and you see that bright light on your wall, but the light is coming from a different source. And your shiny thing is reflecting that light a different way. That's reflection. Then there is refraction. That's the bending of waves due to the change in speed. So it usually occurs when there are different mediums going through it. Okay, so like if I put a pencil in a glass of water, you could see that the pencil is going straight down, and then in the water, it's kind of tilted right. That's because it's going through from a gas to liquid, and it's just bending the light waves to make us perceive something different. Then there's diffraction or refraction. That's diffraction is the bending of or spreading of waves around a barrier. Okay, so it could either be a little gap or it could be a barrier. Okay, so that's just the bending or spreading of waves around a barrier. So, for instance, if there was a wave pool and we put a wall in between, we would see that the waves, when they come in to the wall, it's going to bend around that barrier. Then there's absorption. That's the energy of a wave that's transferred to the material that it encounters. So just like if you feel the pavement on a hot day, you feel it being hot, right? So that's the pavement absorbing the thermal waves of the sun. Okay, and then there's other wave interferences. So that's when a wave interacts with another wave. There's constructive interference and there's destructive interference. Constructive just means helping. So it's just helping to create a bigger wave. So in this picture right here, you see the two waves are the green and the blue ones. And then as a result, it creates an even bigger wave. Okay. And then destructive interference is doing the opposite. It's not helping. It's creating a smaller wave. So they're kind of opposites of each other, right? So as a result, there's no wave. It's a straight line. And then we're going to be talking about sound waves. So sound waves are a mechanical wave. That means it needs a solid, liquid, gas, or any other particle to create that wave. And it's also longitudinal. So it's going in the same direction as the push or pull. Okay. So just some facts. Sound travels fastest in solids and slowest through gas. Okay, so it will travel fastest in solids and slowest through gas. There's many different factors that affect the speed of sound, such as stiffness, density, temperature, loudness, and intensity, and even pitch. We will talk about this more in our lesson, but here's just what you need to know for right now. Okay, and then lastly, pitch is just how high or low a sound seems. Okay, so this shows it perfectly. So the bottom one, that is the lowest pitch if you play an instrument, and the top one is the highest pitch. And you can tell by how it sounds higher or lower, and we'll get into why during the lesson. Lastly, we are going to be talking about the electromagnetic spectrum, okay, on lesson 4. This is going to be a 2-part lesson because it talks about a lot. But remember, electromagnetic waves, they don't need medium or matter. And they're made of vibrating electric and magnetic fields, okay? So they're interlocking together electric and magnetic fields. Okay? So that's what they are made out of. And again, they don't require medium. Okay, they're modeled through transverse waves. So remember that up and down wave. They're not longitudinal waves. They are transverse waves. And the electric and magnetic fields in this picture we see, the red is electric and the blue is magnetic. We could see that they're perpendicular to each other. So they're not following the same path. They're kind of crisscrossing each other. What can happen with light? So light is an example of the electromagnetic wave. Light can be diffracted. So that's when light passes through a small slit and creates alternating light and dark stripes. So maybe you have seen this in maybe your doorway. So if someone has a light outside of your door and your door is almost shut but has a little slit, this might occur. So it might create these patterns of dark and light bands. And then lastly, we're going to be talking about the photoelectric effect. That is the frequency light can, with a high frequency, a light can actually knock electrons out of metal. Okay? And we'll definitely talk about that more. Okay, and then what exactly is the electromagnetic spectrum? That's just the range of electromagnetic waves, so there's different types, in order of increasing frequency, okay? And frequency just means the repeating waves, okay? So there are many different types. Again, there's radio waves, which has the lowest frequency and the lowest energy. Then there's infrared, visible light, ultraviolet, X-rays, and gamma rays. And we'll talk about that again when we get to it in lesson 4. Lastly, we are going to be talking about light. First, we're going to be talking about different types of materials. What is a transparent material, what's a translucent material, and what is an opaque material? A transparent material you could clearly see through. So an example for this is a window. You could clearly see a window through a window. Translucent is when the image is slightly blurry. So think about a very light curtain. So light can still pass through, but you can't really see what is going on outside, or people can't see in, right? So the image is blurry, but some light passes through. And then opaque, you can't see through. No light passes through. An example for this is us. We're opaque. You can't see through me. I can't see through you, right? Another example is just any object that it cannot be seen through. So a notebook, a dog, an apple, all of those things are opaque. Okay. Then we're going to be talking about mirrors. Mirrors are where light can be reflected to form different images. So exactly what we see in the mirror when we look at ourselves, that's considered a plane mirror. That's just a virtual image, so we're not really there, right? It's reflecting. We're not really in the mirror, right? So that just means it's virtual. And it's upright, and it's the same size as us, but the left and the right sides are reversed. So if you've ever seen why a picture of yourself is different from your reflection in the mirror, this is why. It's because the sides are reversed. Then there's a concave mirror. That's when the surface of the mirror curves outward. Okay, that's when the image appears smaller. So think of the outside of a shiny bowl. So if you look at the outside of a shiny bowl, you can see that your face is a lot smaller than it actually is. Okay, that's considered a concave mirror. And then a convex mirror is when the surface curves inward. Okay, so like the inside of a bowl. That creates a larger image or even an inverted image depending on the closeness to the mirror. Okay, so let's just talk about the larger image. So if you look inside the bowl, you could see that your face looks larger than it actually is. Okay, that's because the surfaces are curved inward. Okay, and then we'll get to the inverted images as we talk about this lesson on lesson 5. Okay. Lastly, we talk about light and lenses. We are on the lesson 5 light, but next we talk about lenses. Lenses are just a curved piece of glass that bends light. So the lenses in your glasses are a type of lens. The lenses that are in a telescope or a microscope, those are all lenses. So there's 2 different types. There's a concave lens. That's when it's thinner in the middle, and thicker at the edges. Okay, so that's this bottom one right here. It's thicker in the edges and thinner in the middle. Okay, and that forms an upright, so it's not upside down, and it's also a smaller image. Okay. An example of a concave lens is a peephole. Then there's a convex lens. That's when the lens is thicker in the middle and thinner around the edges, so right here. Okay, that forms a larger image when you're far away, and a virtual image when the object is close. And again, we'll get into that more when we talk about it during lesson 5. All right, so that's your introduction for this unit. If you have any questions, message us, and I'm excited to start this with you. Thanks.